very excited to do a Compton scattering multiple choice question. There's not many of these available, so take this one seriously, have a go, and then when you're ready, please hit play. Okay, so we're looking at interactions between our Compton scattering, our photon of wavelength lambda 0 and frequency f0, and then we know the frequency and wavelength after, which are lambda and f. Okay, so it's worth reminding ourselves what happens in Compton scattering. What you have is change in wavelength of a photon due to the interaction with an electron. And what always happens, well, let's think about it this way, our photon loses energy, and what that does is it increases the wavelength. So we've got this equation here, which I've just noticed a typo there, my apologies, this should be lambda f take lambda 0. I'll find some time to kind of change that at some point. We have an increase in wavelength, so effectively we get red shift. Okay, so in the result of this is that this is always greater than 0. You can see 1 minus cosine theta. The maximum that cosine theta can be is 1. Okay, for any other angles it's going to be less than 1, and therefore you've got a greater than 0 answer here. It probably should be greater than equal to 0. Please forgive me for that one. So the end effect of this is that the final lambda is going to be greater than the original one. In other words, lambda over lambda 0 is going to be greater than 1. Again, cannot say this more times. I feel like I'm repeating myself. We need to rule out answers. So this is why C and D are out already. Again, it's a good time-saving thing. You might not know how to answer each question exactly. However, what you can do is improve your chances of getting the answer correct, and that would be by ruling out answers. Now, the next one is a bit harder, but when you see it, you'll know the answer straight away. We're asking the product of lambda and f. Now just think about where you've seen that before. Yep, that's the wave equation, frequency times wavelength. Well, we know that regardless of the frequency and regardless of the wavelength, that this always multiplies to be the speed. In this case, this is the speed of light. So the two values must multiply every time to make the same speed. In other words, the ratio of lambda times f divided by lambda 0 f0 is going to be equal to 1, which is why the answer here is A. Now, I really like this question because it's one which combines two elements of this. You've got the particle nature of light here, using our Compton scattering, and then you've got the wave nature of light here. And remember what we said, wave-particle duality. At times, our photons behave like particles. At times, light behaves like a wave, and therefore, you're able to use both equations kind of at the same time.